John Donahue is the Construction and Materials Liaison Engineer at Missouri DOT, where he has more than 16 years of experience. John is active in AASHTO Committee on Materials and Pavements and previously chaired the AASHTO Ware Task Group on Pavement ME design.
I'm going to be talking about concrete full depth repairs. I'll discuss a little bit initially what full depth repairs are supposed to address. One thing though I want to emphasize though that is full depth repairs are basically the equivalent of open heart surgery on concrete pavement. I preach to my project offices always to attempt to do a lesser intrusive fix, if at all possible. Partial depth repairs, as Mike went over, and incidentally too, we're also indebted to the work that Minnesota did. We started doing partial depth repairs, Dowel retrofits, cross stitching about 20 years ago, and again we did rely heavily in Missouri too for information and specifications for Minnesota. They did a lot of good research on this. But full depth repairs have been around forever, almost as long as concrete pavement repairs have been around. When you do a full depth repair, the concrete pavement is never the same. As effective as they are, you've essentially lost all aggregate interlock around the perimeter. It's being supported by the steel at the joints and basically whatever base that it's resting on. You have to look at it from that perspective as well, as that this isn't something that's expected to last as long as the original concrete pavement. However, it can be a long-lasting fix. Just some examples of what this addresses: a blow-up, which is basically a tenting of the concrete pavement slabs on either side of a joint from compressive forces. Usually you severely spall or sometimes completely disintegrate the concrete at the joint interface. And shattered slabs, I think by definition a shattered slab is any slab I think it's broken into 3 or more pieces. I'm sure the definition could vary depending on who's assessing it, but if you have a single crack, if it's a longitudinal crack, you might be able to use cross stitching. If it's a transverse crack, you might do Dowel retrofits. So I don't panic when I see a single crack across a concrete slab, because there's other techniques that can be used to address it. If it's broken into multiple pieces though, then it starts to be rendered ineffective as a supporting platform for traffic going over it. And then severe spalling, just in general, and this is usually spalling that goes down more than 1/3 or more than half the depth of the pavement slab. If it's less than that, then again, a partial depth repair could be a suitable repair technique. In this example here, I'm pretty sure that the spalling does go down to roughly the bottom of the slab. And in that case here, as Mike said earlier, you're not trying to weld 2 slabs to get that deep. Pretty much limited to doing a full depth repair. Durability issues such as decracking, which is unfortunately common in part of Missouri. I know other states have the issue too with poor limestone aggregates. ASR, which isn't really a problem for Missouri, but is a problem for other states, is another deterioration of the concrete but in this case here, you're buying some time, but a full depth repair isn't going to be a real long-term effective solution, because the deterioration could keep advancing within the original pavement. So you can remove enough area to where it appears you're capturing all of your problem, but inevitably it's going to start nibbling away at the edges of the old pavement that's still left. You have to carefully assess whether or not a full depth repair is the right thing to do, because you may just have to replace the whole pavement. As far as the limits of concrete removal go, usually you're replacing the lane full width. And one thing I did forget to mention is I want to provide a little disclaimer here that what I'm going over and what I'm showing an example of is appropriate for jointed reinforced concrete pavements, longer pavement slabs with reinforcing mesh. It was a common design used by a lot of agencies up to about 20-30 years ago. And this also applies to the more prevalent jointed plain concrete pavements with no steel reinforcement, but shorter joint spacing, which the majority of states would currently use as their preferred design. What I'm not going over is how to do this with a continuously reinforced concrete pavement. In that situation there's a little more involved as far as basically chipping away at the concrete on either side of the open slab, and basically being able to tie in the reinforcing steel developmental length exposed of the steel on either side of the repair to tie into, because you have to recreate the rebar continuity across the patch. So I'm not going to be discussing that, but that is how some states do design their pavements. So the minimum length, as far as the width goes, I said typically full width, but it can be half a slab if you're trying to save money on a project. You might be going over budget with it, and so you want to scale back on some of the repair limits. You can do that. It looks a little funny. You may create a critical stress point at the corner of the saw cut in the middle of the slab, where potentially you might have another crack start forming from there. But we've done it a number of times, and overall they work all right. The minimum length is typically going to be 5 to 6 feet. That usually captures the footprint of the distressed area of the pavement that has to be replaced. There is a practical limit to how narrow you can make the repair. One limitation is the area or the room you need in order to get the drill into the pavement to drill holes for dowel bars or tie bars if you're putting them in. Also too is concrete tends to prefer just naturally a square shape factor, and if you're making it too extreme as far as the width to length ratio, then it'll probably have a higher likelihood of forming a crack in the middle. When you do the full depth repairs, you do want to go around the entire perimeter. It's tempting if you have an asphalt shoulder not to saw that side, but if you try pulling the slab out without sawing that, you could create a jagged edge. It doesn't look good, and in the end, you'd be a lot better off just going ahead and sawing that. And this is just showing an example. And the left-hand side there, you see a picture of what I was talking about. That's sawing along the joint. From the slurry, everything looks gray, so it's hard to tell what the material is, but the top layer is actually about 4 inches of asphalt. That was the original, that's the shoulder. And then below there is the aggregate base. You can see a lot of the base already pulling away under there. But if we didn't saw that, and if instead we just tried pulling the slab in that situation, a lot of the asphalt probably would have come up with it. So we wouldn't have the nice neat perimeter around the repair area. As far as lifting it out, typically a track hoe bucket is the way to go. Depends how big the slabs are. Just to some degree, it depends how the agency is going to pay for the removal. If you have saw cutting as a separate pay item, you may limit the number of saw cuts that a contractor can do. In our case here, we'll pay for saw cuts down to basically a 12 by 6 slab being removed. We're not going to pay for splitting that slab in half. So that's on the contractor. So they can try removing the 12 by 6 if they want to, or they can saw it on their own dime and remove the smaller pieces. Sometimes for smaller slab removals, even a chain on a front end loader might do the trick, but usually because of the weight involved here, you'll need something about the size of a track hoe. One problem with not getting, well, a couple of things contribute to this. If there's some aggressive forces in the old pavement, the full depth repair perimeter is sawed, and then all of a sudden it closes up simply because of the compression on either side of it. And then when the slab is pulled, sometimes it'll catch the edge of the existing concrete on one of the sides and cause spalling. In this situation here, what you're seeing is the repair performed after the slab had been removed. The lower half of that is the regular full depth area. That top portion that's circled is where a spall occurred, and they had to do a partial depth repair to repair that area. Now, after the slab is pulled, the old slab, the base has to be recompacted. You may have to put some more material down too to bring it up to whatever the design thickness level is. Generally, for short lengths of repairs, you don't have to put in tie bars. Tie bars are meant to prevent slabs from walking or lanes from walking away from each other. And if you're only cutting out 6 feet or so, that's not going to be a problem. You do have longer repairs, maybe 30 feet or longer. You might have a policy of putting tie bars in. I'm not, for the length of repairs we typically do, I'm not overly concerned about tying in longitudinal bars. Now, as far as transverse joints go, we use, and this could vary by agency, we use a maximum 25-foot length without having to put in a mid-panel joint. Some might argue, and I wouldn't dispute what they're saying, is that maybe that limit should be something like 20 feet. But anyway, you don't want the slab to get too long to where you're going to wind up with an uncontrolled transverse crack in it. So you will, if you get into longer joints, you will have to put some baskets to form joints in the center. And if you can, it is kind of nice to match adjacent joints so that you have the same movement occurring, same opening and closing occurring across the entire lane width or multiple lane width. It's just not always doable though, especially for a short repair. It's unlikely you're going to be able to match existing joints. But if you can for the longer ones, then it is more ideal to do that. And this is just kind of stepping through what happens in a typical repair. I'm showing you placing the base rock and compacting it first. You will notice though that they had already drilled the dowel bars. It could really be done in either order. You can drill the bars and then do this, or place the base rock and then drill. One thing you can't do though is you're not going to be placing base after the dowel bars have been inserted, because they're going to get in the way of moving rock around and compacting it. So here we're with a loader, they're going ahead and dumping some rock in there, and they've got a whacker in there, they're recompacting it. And then also too, they're monitoring what the thickness is, just to make sure that we have the effective design thickness of the slab board. For drilling dowels, ideally you would want a gang mounted drill unit, one for production rate efficiency. You can obviously drill more holes faster. You also have more uniformity as far as the alignment of the dowel bars go next to each other. You know, whatever works. I mean, a single drill unit would be fine too as well, but you do have to pay attention a little bit more to making sure that the hole alignment is within spec. And then this is what I mentioned earlier about the fact that physically you are limited to a certain, or a minimum width, practical width, that you can create for full depth repair. And you can see somewhat, isn't the greatest picture, but you can kind of see that, you know, you need some working room to get the drill inside the repair area. For the dowel bar installation, limit on skew, horizontal or vertical skew, we use 1/4 inch for an 18-inch bar, and that's kind of a common skew tolerance to use that a lot of agencies would have. The dowel bar end does have to have some type of bond breaker on it. You don't want it locking up on both sides of the slab. And then when the bar is placed in there after the epoxy has been injected, make sure that the bar is twisted. That way you get good coverage of the material, and you're eliminating voids within the grout, or I'm sorry, within the epoxy. And then finally, placing plastic washers over the bar that basically holds in the epoxy so it doesn't drip and get inside basically form within the new joint and possibly cause some compressive hot spots within the slab, within the repair area. It's just showing the injection sequence, and then placing and twisting the bar. Now, one thing I kind of regret this particular slide, or there's a few slides from the same repair. It doesn't take an eagle eye to see that there appears to be a crack running horizontally across in the middle of the slab. I'm pretty sure that is a real crack. I think it would have to wash away the there to get confirmation on that. But it does appear that we did create a mid-slab crack, probably from drilling the holes, and that does happen on some slabs. So we might compromise the effectiveness of this repair because we do have potential spall zones on the side of the existing slab. But just, for the moment, pretend that we don't have that problem here. And this is showing you the proper way to drill and install dowel bars. And finally, placing the plastic washers over the ends of the bar. And of course, if it's long enough, as I mentioned, there is some maximum limit that you should go without having any mid-panel joints or mid-repair joints. In this case here, you can see the basket being placed in the middle of that repair. Roughly, I don't know, I guess that's roughly maybe a 20 to 22 foot long repair. So we're placing it, forming, shorter joint spacing, but shorter joints are not bad. It's not placing enough joints, which can be bad. For the placement and curing, as far as the material goes, typically you're going to use some type of high early strength material, unless you have the luxury of keeping a lane closed for several days. You can get by with more conventional materials. I am not a fan of either. We allow it, but I'm not a fan of either calcium chloride or type 3 cement. Calcium chloride it's a good accelerator, but long term there are issues. I mean, having chlorides in concrete is never going to be a good thing. You do have the risk of corrosion. Type 3 cement, you get high early strength, but long term you don't get as high a strength as you would with just regular type 1 cement. It is important to make sure that the material is vibrated well enough around the dowel bars. Don't like to overfinish it, or it could wind up with scaling on top. And then finally, either using a curing compound, conventional compound, PAMs, or just placing wet blankets, which you can do with smaller areas of repair. You can get by with blankets that are large enough to cover it. We use an opening strength to all traffic of 2,000 PSI. Not everybody would do that. I think generally, though, we're probably within the ballpark of what most agencies would use. There's some that would even allow a lower strength. We don't feel comfortable doing that, and some may not feel comfortable going as low as 2,000. But that's an agency preference. But we believe we can get by safely with 2,000. As far as the source of the material, if it's a large enough project, you might have a central plant set up by the contractor. Could be using ready mix. In this particular case, you can see there's a mobile mixer on site to do this, and that's because we're using a specialty, a polymer modified high early strength mix, something that wouldn't be available from a ready mix plant. This is just showing filling in a couple different holes. That one small one on the right-hand side, and you can see the one on the left-hand side in the center where we have the basket in the middle of that longer repair. If it's not too long, there's usually a roller screed out there that's long enough to pull across, and that is a handy device. If it's too long, it's a little hard for two guys to carry around, but usually it's relatively portable, and does a pretty good job of vibrating the concrete. Now, these particular pictures, you don't see anybody using a hand vibrator. The workability, the slump is right of the material. You may not need it. We probably I'm assuming we got good consolidation around the dowel bars. So using the roller screed was probably effective enough for these repairs. Finishing the surface, if it's not going to be diamond ground, you want to at least do a broom finish to provide some texture on it. Pulling blankets across, and they kept wet blankets in that tote that you see in the upper left-hand corner, kept them saturated. Put them out there, had enough to use, so they didn't bother using curing compound for these repairs. One thing that does seem to happen on a number of the shorter repairs is that, like I said before, concrete likes to crack in, just naturally likes a square shape. And in this situation here, now to some degree this was sympathy cracking, because you had a longitudinal crack that existed in the old pavement, and you could see that it reconnected across the patch. But even without the longitudinal crack, it's not unusual sometimes to see that longitudinal crack forming. And I don't panic when I see this, because you can have that and still more or less have an effective full depth repair for a lengthy period of time. So a single longitudinal crack doesn't necessarily mean that the repair failed. As far as setting up a job, I'll just discuss a little bit the typical contract pay quantities that you want. Furnishing and placing concrete would be obviously the main deliverable. You could separate those into placing by the square yard, but furnishing by the cubic yard. The advantage of that is if there's uncertainty about the depth of the repair, which wouldn't be a problem when you're just repairing in concrete pavement, but if you're doing a full depth repair in composite pavement, you don't always have the correct pavement histories to know what the actual depth of the asphalt is. So to be fair, you could pay for furnishing the concrete by the cubic yard, and that reduces risk for the contractor. And then some of the lesser pay items, sawing, paying for that by the linear foot, compacting base, which is by the square yard. Usually compacting base would include adding some material. Our experience, we typically have had to do very little recompaction of base for most of our full depth repairs. So we're usually underrunning this pay item. Paying for dowel bars either singly or by the basket. And then if you are putting in tie bars, paying for those individually as well, which would include all the effort of drilling the hole and inserting it, epoxying it, everything. Okay, expected performance. Typically everyone likes to see somewhere between 10 and 20 years. There have been full depth repairs that have gone a lot longer than 20 years. There's others that have lasted a lot less than 10 years. Usually that was a result of poor workmanship or poor materials. So if you can't get 10 years out of a full depth repair, there's usually some obvious reason for why that. Full depth repairs and composite pavements are a little trickier because it's difficult to drill in a slab at the bottom of the full depth repair, because you may have, well, we've had up to 12 to 16 inches of asphalt piled onto an old concrete pavement. So first of all, getting the drill down there is a little tricky. And then a lot of times it's older brittle concrete that tends to shell and spall when you try drilling it. So we have had a number of repairs where we could not get effective load transfer across onto the into the existing pavement, and we basically just had to live with a floating slab out there. But again, full depth repairs aren't meant to give you the original design life of the pavement. They're there to tide you over for a period of time until you can do something more appropriate, such as reconstructing the whole pavement. You know, I mentioned too that the load transfer, that the steel load transfer you have doesn't make up for aggregate interlock that you get from monolithic pavement. So like I said earlier, I push to do any repair possible before we do a full depth repair, but sometimes we're just boxed into a corner and you have to do it. One thing we have done lately over the past few years is we're intentionally sawing. You know, I mentioned earlier that you'll get that natural crack that may form in a short repair in the middle. Well, you can anticipate that. You can control it by going ahead and sawing it. So essentially sawing say a 12x6 full depth repair into two 6x6 panels, and that way you should minimize the likelihood of getting any additional cracking. And I did mention earlier, if you have a mid-panel crack, especially in new concrete, I'll get a call from an inspector or resident engineer. They've got new pavement, but they've got a couple uncontrolled cracks that formed, which may well have been because of late sawing. You know, again, I tell them, look, the crack's tight. It's uniformly, you know, either perpendicular or parallel to the slab. So cross stitching or dowel bar retrofit could be a perfectly appropriate solution. We don't have to cut the whole thing out. And that's about all I have. Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.